welcome to this lesson. In this lesson, we want to look at 4 things that you need to know about the galvanic cell. The first thing is we'll learn how to write the oxidation half reaction. We'll also look at how to write the reduction half reaction. Thereafter, we'll look at how to write the overall reaction of the galvanic cell. Last but not the least, we'll look at how we write the linear notation of the overall reaction. Subscribe to our YouTube channel and like this video if you find it beneficial. You can also follow us on Facebook. Let's look at now what you need to know regarding the oxidation half reaction. We want to remember that we have produced a video that helps us to understand that oxidation takes place on the anode on the galvanic cell. So, if oxidation takes place on the anode, what do we know about oxidation? Well, oxidation is the losing of electrons. So this simply means a metal which is in solid state should lose electrons for us to show that it has undergone oxidation. So this metal, which is zinc, is becoming zinc 2+. It is now becoming charged. So zinc 2+ as a charge there. Then it is in aqueous state. After we do this, we balance off the electrons. So how do we balance off the electrons? The reactant side is having the overall charge of 0. The product side is having the overall charge of +2. So we introduce 2 electrons to balance up the overall charge. And remember, these electrons have been lost, hence proving that this is an oxidation reaction. Let us look at now the reduction reaction. Remember that reduction takes place on the cathode on the galvanic cell. Now, what do we know about reduction? Reduction is the gaining of electrons. So if a reduction reaction is taking place, electrons should be shown as gaining. So this simply means the copper ion should gain the electrons to become copper solid. So we are simply saying the copper ion, which is of a +2 charge, it is in aqueous state. It is gaining 2 electrons for it to become copper solid. And this is the reason why even the size of the cathode increases, because more solid substances are being accumulated on the cathode. So this takes place on the cathode of the galvanic cell, while oxidation takes place on the anode of the galvanic cell. So how do you show the overall reaction of this reaction that is taking place in this galvanic cell? Well, the overall reaction is very easy for us to show it. We simply put the reactant parts of the oxidation and the reactant part of the reduction together for us to come up with a redox reaction. So we have zinc, which is solid, on the reactant part of the oxidation. Then we have copper ion, which is in aqueous, on the reactant part of the reduction. Then this is producing zinc, which is in aqueous, on the oxidation. and copper, which is solid on the reduction. Now, you'll notice that the electrons are not shown on the overall reaction. And the reason is very simple, because these electrons can simply simplify. So this is how we write the overall reaction of a galvanic cell. Now that we have this overall reaction, let us look at how we write the linear notation of what is happening in this galvanic cell. So when writing the linear notation, we start with what is taking place on the anode, then thereafter we look at what is taking place on the cathode. This is separated by a short bridge. So what is happening on the anode? On the anode, we know that zinc, solid, is undergoing the reaction, that is oxidation reaction, to produce zinc ion. Now, this is separated by a line, then we put zinc ion, which is in aqueous. After we do that, we put two lines to show that there is a short bridge that is separating the oxidation and the reduction part. Now, when we go to the reduction part, what is taking place on the reduction part? We can see that copper, which is ion, copper ion in aqueous state, it is a reactant. Thereafter, it is producing a copper metal. So copper metal, which is solid, is being produced there. So you can now notice that there is the representation of the anode and the representation of the cathode. So this is how we write the linear notation. So what have we looked at in this video? We have learned how to write the oxidation reaction. We have also learned how to write the reduction of reaction. We have looked at how to come up with the overall reaction. Thereafter, we have also looked at how to come up with the linear notation. So look forward to a video where we'll now do calculations that involves the galvanic cell. Don't forget to subscribe to this YouTube channel, Zuluba Consultants, and the Facebook page, Zuluba Consultants, for this and more videos.